Alright, so we are starting Unit 3, and Unit 3 is going to be dealing with linear functions. Before we move on to linear functions, we're going to do a quick little review about domain and range. Okay, so we have a picture here of a graph. Alright, you'll notice it has an open circle and a closed-in dot right there. It says, determine the domain and range and represent the domain and range using inequalities. Alright, and then identify the domain as continuous or discrete and justify your reasoning. Well, this is continuous because right now I would not be able to lift my pen if I was drawing that line. So this is continuous from here to here. So we call that continuous. But quickly, let's go over domain. Domain always reads from left to right. And the range, which deals with your y values, goes from the bottom. You always read from the bottom all the way up to the top. All right. So if you were to draw this picture, if you're taking notes, if you draw the picture, this right here represents your domain. So I'm going to write the word domain. Remember, the domain deals with the set of your x values from left to right. And then right here, this is the range. That's the range of the graph. So I'm going to write the word range. And the range deals with your y values from bottom to top. You always, right? So what I want you to do is I'm going to put minimum, like how low does it go and how high does it go, and then how far to the left does it go and how far to the right does it go. So let's start with the domain. It looks like it gets all the way over here to -7, right here on the x-axis from -7. All right. Oh, what am I saying? That's not -7. Dude, you're totally wrong, man. Come on. Duh, it's between -6 and -4. That's -5. But it does go all the way over here between 6 and 8, which is a 7. So the maximum that it gets is a 7, and the minimum that it gets is a -5. Now you'll notice there's a closed-in circle for the max, and then there's a open dot. Okay? So let's take a look at our range. It looks like our range gets all the way down to a -3. Okay, right there, -3. It gets all the way up to 5. So it gets all the way up to a 5. All right, and it gets all the way down to a -3. Now you'll notice up here this is closed. All right, this is open. Now that's going to really impact how we write our inequalities, okay? So you'll notice I put my inequalities in between. So the maximum, all right, which gets to a 7, all my x values right here are less than or equal to. So by the way, a closed-in circle, this means equal to. When it's open, it means not equal or does not include. All right? Not, it's supposed to be an E. So I'm going to put not equal. Okay? So it does not include this ordered pair. It does include this ordered pair. So my x values are less than or equal to a 7, but they're just greater than a -5. So here's how you read it. X is greater than a -5, but x is less than or equal to 7. How do we read our inequality for our range? Our y values are less than or equal to a +5, but they're simply just greater than a -3. And so when it says you're supposed to use this thing called inequalities, this is how you are going to see your answers, like this right here. Okay, so those would be my answers as inequality. All right, so there's your answer there. Now what we're going to do is we're going to talk about slope and rate of change. All right, so what we're going to do is we are going to go over to Desmos. All right, so we're going to go over to Desmos test mode right here, and you can find this Desmos test mode star version. This is what you can use on a star test, and we're going to actually build a table. Okay, so when you build a table, you hit this little plus sign. We're going to make a table, and then we're just going to take the numbers that we have. So at -5, 7. So we're going to type in -5, 7 in, here's the cool thing, you can see it plot right there. There's the -5, there's that point, -5, 7. Alright, and we're going to type in a 1 and a -5. So I'll type in a 1 and a -5. And you can clearly see where that 1 and -5 is as you're typing it in. So it's kind of a cool tool to use while you're, working on your test. Alright, got a 4 and a -11. Now you can't see that -11. I'd have to zoom out, but if you zoom out, you can see the 4 and the -11. You got a 7 and -17, 7 and -17. And so you can still see, there it is right there. And you can kind of see a pattern developing. You can almost see the line where all the dots are connected. And then finally we have what? A 9 and a -21. So you can't really see that unless I do what? One more thing, I got to zoom out. So now you can see all the ordered pairs right here. So once again, how do we do that? We just hit the plus sign and you make a table, and I want you to be able to do that. When you're taking a test, I want you to know how to make a table and be able to interpret the points. And you can almost see, if you visualize it, you can see that all those points, if we connected them, they would form a line. And this line has what's called a slope. It has a specific slope to the line. We're going to talk about how to find the slope of this particular line. So let's go back over here. All right. And before we find the slope of the particular line, let's kind of talk about what slope is. Okay? So right here, we have some examples of slope. So right here, it is totally flat. We call this line, we call this a zero slope. Now, if it goes down from left to right, we call that a negative slope. But if it goes up from left to right, we call that positive. So these are just examples of different types of slopes that you will see. Now this one, it doesn't go up from left to right, it doesn't go down from left to right, from left to right, it doesn't do anything. It's a vertical line. Now this is not a linear function, but it is an equation. It's actually the equation x equals -3. And we call this slope undefinable. So we call it undefined. So anytime you have a vertical line, it's going to be undefined. Now, this has a slope of 0, but right across here, you can see that it passes the y-intercept at 2. So this equation is y equals 2. All right, that's the equation. Y equals 2. All right, so this is a continuation of a video I already started. I've already talked about this is a slope of 0, this is undefined, this is negative, this is positive. Okay, but we can also actually find the actual slope. Now this means f of x or y equals, this is always equal to a constant. So if I were to go to, say, Desmos, let me go to Desmos real quick. All right, and I were just to type in, for example, y equals 4. That you can see that this is a 0 slope. It's just y is always equal to the number 4. If we zoom in, you can see that the y value is always equal to 4. Now, you could also type it in function notation where you do f of x equals 4. And you'll still see that these mean the same thing. So y equals 4 and f of x equals 4, they're the same graph. Okay? So that's called the slope of 0. Now, what would be an undefined slope? If I put like x equals 4, all right, or x equals 3. Or x equals 2. So this is x equals a constant will always be an undefined line. That's x is always equal to a constant. It's a vertical line. So that's why I put x equals 3. That would be, actually it's supposed to be -3, not positive 3. X equals -3. So x will always be equal to a constant in an undefined line. Okay? All right. So what we're going to do next is we're going to show you actually how to use the slope formula. So we'll do the quote textbook way, and then we'll do the an easier way, in my opinion. So go and get your journal when you're writing this stuff down. Okay, so we're going to go right here and take a look at this. So we have this table, and you can clearly see the table. You should have it in Desmos if you're working along with me. There's all of our points right there, and you can kind of see they form a negative slope line. Okay. So what I want you to do is I want you guys to write the word slope like this, slope. Now the slope means it's talking about the rate of change in a line, the rate of change. But what does rate of change actually mean? Basically, we're going to be finding what's called the change in the y values over the change in the x value. So it's the change in y over the change in x. Now you will see me often write delta y over delta x. And delta means change in. So it's just a faster way of saying the same thing. Change in y over change in x. Now the slope formula, and slope is referred to as a lowercase m. All right? Every time you see an m, I want you to think slope is equal to y2 minus y1 over x2 minus x1. This is the slope formula. So any formula chart, this is what you're going to see in a formula chart. But what does y2 minus y1 mean? It means the change in y. What's x2 minus x1 mean? It means the change in x. Now we can actually choose any ordered pairs, any set of ordered pairs that we want. So I'm actually just going to choose the negative 5 and the 7. So I'm going to choose negative 5 and the 7. And then I'm also going to choose 1 and negative 5. I'm going to choose 1 and negative 5. So I could have chosen any set of these ordered pairs, but I'm just going to choose these ordered pairs. Now it's important that you label them correctly, otherwise it'll mess up. So I'm going to call that my x1 and my y1, and I'm going to call this my x2 and my y2. So when you're doing the slope formula, it's going to be important that you use parentheses because they matter. And if you don't use them, then there's a good chance you might mess up or get something wrong. So I'm going to do parentheses minus parentheses over parentheses minus parentheses. So what am I going to plug in? I'm going to plug in my y2 there, and my y1 there, and my x2 there, and my x1 there. All right, so if you have that ready to go, all you got to do is take your y2, you plug it in right here. You take your y1, you plug it in right there. Okay, take your x2, which is 1, and you take your x1 and you plug in a negative 5. All right, let's see what we got here. Let's see what we have. All right, so negative 5 minus 7 is just negative 5 minus 7, and that yields me a negative 12. But 1 minus a negative 5 actually becomes 1 plus 5, because a negative times a negative is a positive. So when you're doing it this way, you got to be very careful that these two negatives multiply together to equal a positive. So you got to be careful there. So 1 plus 5 is 6, and negative 12 divided by 6 is negative 2. Now what does that mean? That means I have a slope of negative 2. That means the line goes down 2 over 1. So it's negative 2 over 1, which means this line goes down 2 units and over 1 unit. Okay, so I'm going to kind of show you that over here in Desmo. So I'm going to zoom in enough so that you can kind of see that pattern. Okay, so here we go. We said the slope is what? Negative 2 over 1. Watch. Down 2 over 1. Down 2 over 1. Down 2 over 1. You can kind of see the pattern that these points take. No matter where I go on the graph, if I go up a little bit more, and I start from here, eventually I will reach this point by going down 2 over 1. Hopefully you can see down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. It keeps going. All right? So that's kind of how you can find slope. Now we can also find it in a table by finding the change in the y and putting it over the change in the x. I'm going to call this the change in y. I'm going to call this the change in x. If I go from 7 to a negative 5, that means I went down 12 units. If I go from negative 5 to 1, that means I went up 6 units. Let's do another one. Ready? If I go from negative 11 to negative 17, that means I went down 6 units. If I go from 4 to 7, that means I went up 3 units. Well, check this out. If I said it's the change in y over the change in x, you can clearly see that whether I put negative 12 over a 6 or 6 over a 3, what do I still, negative 6 over 3, I still get a what? A negative 2. And I'll continue this video in a second.